Okay, fantastic. Yes. So who am I? I work at Dell Software, as mentioned, as an engineering advisor. So I do advisory service internally, and I manage the Visual Studio ALM deployment across Dell Software. We have several ALM tools, several DevOps tools, the Atlassian suite, VSTS, TFS, etc. I manage the Microsoft side of the story. I'm also a PSM1 and a Visual Studio Development Technologies MVP. That's the new name for saying that I work with ALM. So I work with VSTS, I work with the build, and so on. But I'm also a community nut, okay? I love staying with communities, talking to communities, and being among community members. I founded the Taunton Developers Meetup. I helped run the London Microsoft DevOps Meetup, and I founded and helped other communities overseas. In the DevOps world, I'm more into the development, but I'm the nut with the servers at home, with Xeons at home. Okay, so I'm planning to buy a rack. I'm the kind of guy who does something 9 to 5-ish, but then at home has all its interest to try new stuff which is outside of a comfort zone. So I'm kind of in the middle. This is the typical flow we saw during the last years, iterative development. There is no real name, there is no real label here, but from the product backlog, we have some sprints, iterations, however you want to call them. You get something which works, and then you should have an operational backlog which is made of problems from production, which you gather from monitoring. This problem will be analyzed and then sent back to the product backlog for fixing. That's pretty much the iterative development we should be used to. When approaching DevOps, are we actually all ready for it? Is there anybody who's just looking around and evaluating to move for a small project, for a big project, whatever, DevOps? Okay. So you would see that sometimes when operating a cloud service in a DevOps way, but also with on-prem products in the DevOps world, things are the other way around. Okay, so you don't have a fixed milestone, which could be alpha, beta, whatever, but you should have a minimum viable product, which should include infrastructure, which should include the pipeline working from the very first moment. That's kind of a radical shift from typical enterprise development where you start working for 6 months on an alpha version, which needs to be ready for date X, and you get everything in the working. It's not like this, okay? You have dev and test environments which should be disposable, okay? You should be able to destroy the test environment or recreate it. They become a commodity. Infrastructure must be idempotent, so you need to run the same script every time, 100 times, and you should expect for 100 times the very same result. This is different than the typical non-agile, but also with agile, with the typical enterprise development model. You will see that testing can happen in production, and that's very handy for several reasons. But if you think of this on a typical enterprise development role, how many times does this happen? Fairly rarely. Okay. It is a big shocking change for some. Those are answers for my interviews for 20-odd people. Usually, people are scared. If they come from a traditional development background, people are scared because they feel the lack of a safety net. They don't feel confident. A typical operation guy who's always so VI for creating his scripts, or who just did scripts or systems maintenance, approaching Visual Studio for the first time. It's kind of scary, okay? And I get that. It's fair game, okay? I understand. The first time I saw Git myself, coming from a fully Microsoft shop, fully Microsoft experience, I struggled. But again, it's fair enough. It's a change. The human being is resistant to change. So I understand these answers. I also understand we don't want to be accountable for all of this. When you have separate teams, development, testing, support, operations, people don't want problems from other people. Instead, everybody should be accountable for the slice of what happens. So if a certain feature goes into production and there are problems 2 in the morning, I might be wrong if I'm accountable for it. And again, it's fair, because then the developer won't push code which fails at 2 in the morning. Okay. First time it happens, second time we think twice. How do we know what to build? That was a very good answer. We moved to the pipeline, we moved to a new model, continuously deploying stuff, but how do we know where to start? How do we know what to build? That's where data helps. So having an idea of what the users are asking for really helps. So the prerequisite is, bottom line, the team must buy into DevOps. If you have people resistant to this change, if you have people who are just 9 to 5 and they just don't care about DevOps, they don't care about these things because for the last 15, 20 years, their product worked fine, their pace was nice as is, there's no way of adopting it. Just forget about that. But if you start doing that, the first thing you should do is to use your infrastructure, to actually use what you have at your disposal, okay? So if you're going towards Azure, if you're going towards Amazon, AWS, this is an example coming from Azure of Azure Resource Manager, sorry. This is an infrastructure definition, okay? 2 websites, a SQL server, firewall rules, the hosting plan for app service, everything is defined. I can redeploy this stuff, and every time I will get the same results. This is not done by an operational guy, but this is done by a developer, okay? This is done with a developer tool. So this doesn't mean that the developer will have access to production without any kind of control or whatever. This means that the developer collaborates with production, with operation, in order to get an infrastructure which is going to be fine for both requirements. And it doesn't mean that developer checks in his code and that's it, then infrastructure is someone else's job. It's not. It means that people will collaborate into getting a working infrastructure better and faster. You should leverage on infrastructure as code, of course, or DSC as we saw today, PowerShell, Azure Resource Management, Amazon, whatever. It could be literally a set of scripts if you want, okay? With PowerShell DSC, you define your own set of scripts. Those are the scripts, that's it. You just change parameters. You need to remove friction. So that's the underlying foundation. Remove barriers, remove frictions. Okay, spend time on defining what you need and ask a provider, Azure, AWS, your local scripts, whatever, to deploy them for you. The lesser human interaction there is in this phase, the better it is. Okay? It should be idempotent and resilient, which means that if there is something wrong, it happens all the time. Cloud services. I'm deploying new stuff, I get a timeout. It happens. Congested network from whatever location in the world. Fine. Redeploy. Launch another deployment. I don't care. I don't have to care about if there is something wrong, there is something stuck in the middle of some operation. I just redeploy that. That's it. And having less friction here means that development people, operational people, also managers, I can tell you, they have a better interaction. There is much less friction. People is even encouraged on going towards this kind of collaborative approach. And it works. And it's a fundamental change. Because especially with certain organizations, I can say that there are silos, completely separate people, completely isolated people, which are not going to talk to people in a different division, different team, unless there is someone telling them to, because of certain reasons and so on. This kind of politics, this kind of friction just doesn't have to be in a DevOps role. And then we'll bring the very first example, okay, of potential problems with a team approaching DevOps for the first time. So how do we deploy something to the database in production for the cloud service, for example, with no downtime and without breaking something? Okay, so the first time something like this happens in a team, you need to add the column. That would be the example in my case. You need to add a column to the database. You need to start using it. You need to start using it with no downtime. It's a mission-critical web service, blah, blah, blah. Okay? It needs to be transparent as well. Well, typically, the reaction is leaning towards this button, okay? Because people is scared. When they hear database change, production, they start flipping out. Actually, the typical approach here would be develop everything in a separate environment, countless hours of test, countless environments, maybe simulating different scenarios, then a big bang migration, okay, for development tools. And every new user will get a new feature. There is a big release date. People start freaking out. And lots of fingers are crossed. And usually 99% of the time, it's a bloodbath because something goes wrong in the middle of a procedure, and we get problems. In DevOps, with an agile delivery model, we should do things the other way around with different timescales. So each big change, like changing the database schema, changing the database, generally speaking, should be split, must be split, I'd say, into smaller changes. So the team should be able to understand that if you have this big change for your application, it can be delivered across a multiple number of sprints, okay? It's hard sometimes. I already saw some faces not entirely convinced about that, but it's how it should be done, okay? So if you have such a big, potentially breaking change, why should you deploy it in a big bang mode, while instead you can have silent deployments across multiple sprints with control steps which are going to change the application somehow, and you are way more comfortable with those deployments because they will do a smaller subset of what you're planned, and if something breaks, you can easily roll back to the version before. It's way easier than having a big release date, something breaks in the database migration. Well, we should roll back. Yeah, it's a few terabytes of data. It's going to take long. That kind of scenarios can be avoided by having silent deployments split across multiple sprints. And also, you can start your MVP straight away, which doesn't mean using me straight away, but means using your minimal viable product. So usually, when you start doing this approach, the first people using the MVP would be people writing stuff towards your APIs. Because generally speaking, the user doesn't realize there is something different unless they see a change in the UI. Instead, if the user is going to be someone writing some code against my service, then it's highly likely that he's going to see some breaking change. So let's take a look, starting from scratch here. All right. So you see that decently, yeah. So I'm starting totally from scratch here. This is a fake application. It's a to-do list, okay? It will be running on Azure with a SQL Server database. It will be kind of microservices, okay? Meaning that the APIs are split from the web. This is an example from the Azure App Service team, which is slightly modified. So nothing really fancy. Everything is on GitHub anyway. And I also added an Azure deployment project, which basically is the definition of my infrastructure so that I can run this thing every time. That's Azure Resource Management, in case you were wondering. I can run this every time. This is my infrastructure definition, resources. So what we saw in the slide beforehand, okay? I have two websites with 2 slots each. So I can have a staging slot, I can have a test slot, and I also have a production slot, of course. Then I have SQL Server with a database and some firewall rules, of course, in order to let whatever communicate with SQL Server, and then the Azure hosting plan for the app service. Okay, so that's my infrastructure, which as a developer, I define with my operational guy. What is going to happen is that I'm going to trigger a new build from VSTS. It could be VSTS, it could be Jenkins, it could be TeamCity, it could be whatever, okay? I don't really care about the toolings here. What's important is that I'm triggering an automated build. So your build server is going to build your code from scratch, deploy your infrastructure for you. The definition of this is extremely easy. So you'll see it's a series of steps, really. Restrain the nugget packages, then build my code, push the symbol somewhere, create the artifacts, which is a set of zip files, one for each microservice. And then I'm going to run my Azure deployment task, which here is just create or update the resource group. What I'm going to do is, starting from this JSON file, okay, my infrastructure definition, it's a JSON file. Starting from here, I'm going to push it to Azure, which is my deployment provider, and then Azure will take care of that. I don't have to bother with it. How do I start with this? GitHub, there is a few hundred samples from the Azure Resource Management team. From this example to creating a Linux cluster with Hadoop, whatever, literally, you'll find an example to start from, okay? So it's extremely easy to get started. My build, which I'm going to trigger now, is going to run on my machine. This example, it could be running in the cloud, it could be running on a data center, you don't care, okay? I just hope that the network here is going to allow for this. Otherwise, I will move to the cloud. So what will happen is that I will get the binaries, I will get my zip files, one for each of the services, and then, once I have that, my binaries will be pushed to the deployment pipeline, which we'll see in a second. But before that, my infrastructure is going to be created by Azure after I trigger the build. So I don't have to care about the infrastructure. I don't have to raise a ticket and say, okay, help desk, I need this servers, I need the SQL server, I need these firewall rules, I need these users, blah, blah, blah. I won't do this anymore. This works in the cloud with both Amazon, if you're using CloudFormation, which is extremely similar to Azure Resource Management, or on-prem, if you're using Azure Stack. If you're not using Azure Stack, you can use PowerShell DSC, okay? And into the project here, you also have a very handy script to deploy a resource group with Azure. I created another script to deploy microservice because it was missing. Well, I was missing a task when I created the sample, but still, you can have scripts to start from. So you won't be left on your own. You can create your DSC script, which is going to be pretty much the same. So install a server, go in remote on this machine, execute a set of steps, which are going to be idempotent, as we know, and you will get the infrastructure on-prem. On-prem would be slightly harder, I get that, if you're not using Azure Stack, but still, the approach is that. So you won't have to manually bother about configuring your machine. What you need to bother about is to define your infrastructure together with the operation guys. So,
just to clarify there, the JSON there is for Azure PaaS rather than IaaS, is that right?
Not entirely. This JSON here is for Azure, full stop. I can create virtual machines.
Oh, sorry, but your specific code is...
Oh, yes, it is. It is. Okay, yes, it is. But from here, I can create virtual machines. I can create SQL servers. I can create SQL Azure. I can create Hadoop. I can create whatever there is here on the dashboard. Okay, so whatever artifacts I have on the new list, I can do that with ARM. So let's take a look at the build. The build is done. So after this, I have my infrastructure running in the cloud. I have my binaries. Someone is going to push my binaries, hopefully. And that's the pipeline. In this example, I'm going straight to production, just because it's a demo and because we do not have lots of time, I'm afraid. But what my ARM template did was to create my stuff. So everything here is brand new, okay? I also have staging slots. So we'll have different web application for different stage. And then what will happen is that I'm going to link this with my pipeline in the STS as well. So let's take a look at this. This is extremely simple, okay? It's going to be publish something, well, publish the two websites, okay? One per API. But it could be multiple tasks, and everything can be replicated for different environments. So here I'm going straight to prod in this example. But I can also have test first, automated, and then after approval, I can go to prod, or I can go to staging. Everything is customizable here. I try to keep things as simple as possible, so no approvals, everything is automated, etc. The trigger here is to pick whatever comes from the continuous integration build. So whenever there is a new continuous integration build, my pipeline is going to pick up the artifacts and push them wherever I want. I could have done much more because all the tasks for the VSTS build are pretty much the same for the release pipeline. So all the Azure tasks, all the partial tasks are the same. I can invoke the same stuff. Yeah. So let's see if it's done. Let's open up the releases. It's done. Should be this. Is it? Yeah. And it works. From scratch. Hopefully you should see some data now. So that's cool. Okay, it's a nice demo. But it's not just about deploying stuff. What we were talking about also was about deploying a change to your application. So if we have to add a new column to the database, and you don't want to do this in a big bang situation, which could cause problems, what you should do is to split this into smaller pieces. The first thing would be adding the schema. Why? Because especially with Azure App Service, as long as the schema is not invoked by the model, it doesn't exist. So you will be adding something, you know that it's there, but it doesn't change anything, okay? What I'm doing here is to make this change. This is my schema definition into Azure App Service. I'm going to push this change to the definition. And this will be the end of my first sprint. I will be deploying just this change, nothing else, even if, obviously, it's adding a column, okay? So it's not a big change. It's not a big deal at all. But still, I want to split this because I want to be sure that this change is not going to impact my service. Okay? We won't see anything about this change because the model is not going to invoke the schema. So it's there. It's just there. And only me as a developer, and only I as a developer, sorry, know that it's there. My users won't see them, neither the end users or the developer users, people writing stuff against my APIs. Okay? Nobody's going to see that. Let's take a look at the APIs, meanwhile, just to show you that it's actually returning something. Okay. Visual Studio Code, and let's paste this in. Okay, so here, this is my data. What I will see in the next deployment, so as soon as the deployment finishes here, is that there is no change. And that's absolutely on purpose. Let's take a look. Is it already on? It isn't. Why is this important? This is very important because I know that, especially with databases, things break. Because we know that computers should be deterministic systems, databases should be deterministic systems. But I saw countless times where this doesn't happen, or at least it doesn't seem to be because of some user intervention. So the more I can split this kind of breaking changes, the better it is. What I'm doing here is literally adding a small bit, which is not going to change anything for my user, but it's going to lay the foundation of what would be my change. Is it a waste? That's a question I'm often asked, because I'm adding something which is not going to be used. It could be a column, it could be whatever. It's a bit of a waste. Yes, fair enough. But unfortunately, or fortunately, depending on the point of view, we are no longer where we optimize down to the single bit, especially with the cloud, where those are just commodities. Okay? A column is not going to change anything in terms of billing. It's not going to change anything in terms of performance. So yes, there is a waste. Absolutely agree with you. But it's not a big deal. And it's important to know that. It's a change. It's a mind shift change, especially for people with 15-odd years of development experience on average, because it's hard for them to digest this. So let's see if it's done. So let's go back to the application. It's hard for them to digest this thing. I get it. But with the role we live into, it's far easier to approach things the other way around, so splitting things and doing stuff incrementally, instead of still relying on big bang changes. So the application still works. The API as well. Notice, for this demo, I have a set of data which is going to be replicated every time. It will be recreated every time. That's because I'm completely redeploying my application. So that first set of data will be new every time. You can see this from the created at timestamp. Okay, so 27:31. It won't change existing data. We'll see that in a moment. I will add a new task, and it won't change with existing data. So the second step at the moment would be adding the model, changing the model. In Visual Studio, I will have a model class, of course. A model is a representation of my database table, which is going to be used my application, because my application is going to use an ORM. And I'm not going to write against the DB directly, but I'm going to use this ORM to interact with the DB. Okay? Are you all familiar with this kind of topic? Okay. Generally speaking, it's bad, unless you have certain requirements, to go straight to the DB, but it's better to have an abstraction in the middle, making it very simple. That's why we use ORMs, usually Entity Framework and Hibernate, whatever, because it's far easier for the developer, and it can be easily optimized, to use an ORM in the middle. It makes life way easier. So here, I'm going to add my column in the model. So my abstraction from the database is going to show the new column as well. But it would be null. And bear in mind, this int and question mark means it's nullable. It's a nullable integer. Okay? I'm adding something which can be an integer number, or it can be null. And that's absolutely on purpose. So I'm saving this, and I'm pushing this to my Git repository, which is a source control system. I'm making life simpler here. I'm not going to talk about the difference between local Git repository and remote one, but just bear in mind that I'm pushing my stuff towards VSTS. So, model. Now, the model goes up, and we can start seeing some changes. As mentioned, the first people who are going to see these changes are the developer users. Let's call them this way, the advanced user, the power user, whatever, okay? Which are going to write stuff against my APIs. So here I have a nice UI with a list, I can add a task and whatever. My guys, which are developer APIs, might not use the UI at all. They might just rely on the JSON file. They might just rely on the API themselves, so post, get, etc. And they will see some changes here, because as I'm using a model now, which is going to include my change, obviously they will see the difference. So let's take a look if it's done. Not releasing yet. The build is still queued. It takes a couple of minutes because it's my machine, because there is a bootstrap every time, of course. Could be way faster if I was using a data center with bigger machines. But right, so here I can tell you before it happens what my users will see, what my developer users will see in the in their JSON file they get as a response, is that there will be the new column with the null value. Okay, that's what will happen. That will be the first to notice this, and it absolutely makes sense also from a testing purposes, because from a testing purpose, I might want advanced users seeing changes first and bringing in feedbacks first, instead of my end user, which knows only where to click. And if something changes, it's going to be a new ticket anyway. So it's way better to have this advanced user in the middle. Tell me.
How has that change been made on the database? Is that column being inserted in the table, or is it being inserted at the table?
It's going to be added at the end of a table. Because, no, it's not a breaking change, but anyway, it's because I just added a column, and that's by design. I could have done more, obviously, because it's all code, so I can define how do I want it added.
I guess my concern is that it'll be a breaking change in the schema of the database itself, if the URL is smart enough to actually allow it to be used.
Yeah. We can connect to the DB. I was keeping it for later, but that's fine. So we're going to the DB here. Let me just add the firewall rule for connecting from a client. given that Azure is not going to allow anybody to connect to the database unless they have a client firewall rule. For good reason. So here, this is coming straight from my Azure subscription, so that's why it's already logged.
Quick question. When you create DBs with RM templates,
Yep.
does it ensure that the DB data is persistent and nothing happens to the data?
Very good question. Whenever you create something, well, create or update something via Azure Resource Management, unless you define a specific strategy, new data is going to be kept in. Okay. In my example here, I'm going to re-add every time the first 5 items. But if you have existing data, we'll see that in a second, data will be retained.
So
It's not going to be disruptive.
underlying storage of
So-
SQL Server.
Sorry?
It maintains the underlying storage of
Yeah.
SQL Server.
So this is my table. Oh, and I click on the design surface, but anyway, let's see which is faster. Well, meanwhile, the deployment should have been completed by now. Okay, it works, that's fine, and the APIs should return what I'm expecting. Okay, you see that there is a uref here. That's my new column. It's null, of course, because I didn't add the logic for it. And you see uref is here at the bottom. That's the question about the column. Cool. So my development users will know that there is a breaking change. There is a change. Okay, there's something which is going to change the schema of the application. It's going to change the return data. So now what I'm going to add is the actual logic. But I'm not going to touch existing data. So what I'm doing is a deployment of the, oh, sorry, that's the wrong one. I'm going to add the logic for new data, which means that this void here and this here. Basically, whenever I'm going to add stuff to the database, this stuff will have an ID, which is a new GUID. You good? That's fine. And I will have a uref, which is the name of my column, which is going to be calculated using this, which would be how many items do you have? I have 5. Okay, you are item number 6. You are item X plus 1. Easy. It's crappy code, okay? It's just for demo purposes, but it shows what it does. So I'm pushing this out. Oop. This is my silent logic. Why silent? Because I'm not announcing my feature at all. I'm going to do it anyway. My users don't need to be notified about the change for 2 reasons. That's just for new data, and I can easily roll back. So it's still a silent logic. I can give you another example. TFS. TFS has multiple updates. Okay. At the moment, we are on update 2. There might be other in the future. TFS 2013 had 4 updates, 4 or 5 updates. Well, if you have a look at the logs, you will see that many foundational pieces are deployed between updates, but the feature which I'm going to see in update, let's say 3, was actually silently deployed in update 2, or update 1 even. Okay? That sort of stuff is feasible because of the approach which is used. Because otherwise, if it was a big bang moment, I would have had an enormous amount of time for upgrading. I would have had more problems, potentially, on the upgrade phase. So that kind of stuff is done in order to avoid problems in the future. How much time do we still have? Okay. None?